Welcome everybody. Got a brand new unit to start today. Unit 6, Meteorology. What a wonderful picture there of the hurricane. You can even see the eye wall in the middle. So in this unit, in addition to hurricanes, we're going to learn about all kinds of storms and why they occur, why weather occurs. At this point, we've already had a discussion on the board, a little brainstorm of what might create weather and what might cause weather. So let's just move right on with the lesson. First of all, meteorology, study of our atmosphere, weather, and forecasting. There's this area's top meteorologist, Bob Kovacik, who I saw in 5th grade, came to my classroom in elementary school. Great guy, great meteorologist. Experience counts. So weather. Weather, short-term conditions of our atmosphere. Everyone loves to talk about the weather because it's always changing. And most weather takes place in the lowest layer of the atmosphere, our layer, the troposphere. And here's the troposphere right here, our layer. It extends from the ground up to about 12 kilometers or so. And without this layer, we wouldn't have weather. Okay, so we already talked about the troposphere where weather occurs. This is our lowest layer where we live. And you can see in the picture over there, there's all the clouds way in the bottom of this picture. So all the clouds occur in the troposphere. Moving above that into the stratosphere, which you've all heard of, this is the layer that actually warms up as you gain in altitude, which is, something opposite what you'd think. And the reason why is ozone, which exists in its natural state in this layer, which is just simply 3 oxygen molecules bound together, ozone, it absorbs ultraviolet energy from the sun. And that ultraviolet energy imparts its energy into the ozone layer, and that's why the stratosphere gets warmer. Above the stratosphere, the mesosphere, and temperature here drops again as you gain altitude. Various things occur. You can see, sprites from thunderstorms, noctilucent clouds, meteorites burn up here. The aurora borealis starts in this area, and as we go up into the next layer, there's more of that. The last layer before space, the thermosphere. And once again, temperature rises again due to oxygen and nitrogen energy absorption. This is what's, primarily the reason for the auroras is the solar energy during times of peak solar activity strike these molecules and excite them, and as they give off their energy they release photons of light, and it's really pretty. So these are our layers. In between each of the layers, as we'll see in a few slides, where the temperature pauses and reverses direction are the pauses. This is page 14 in your reference tables. And I'd like you to take a moment, you can pause the video if you're doing this at home, to just write the range in kilometers to the left of each layer. For example, the troposphere is located between 0 and 12 kilometers. That's an estimation. You can see on the left-hand side, the numbers go, or the marks go by 10-kilometer increments. And the right-hand side, they go by 5-mile increments. But if you could just take a moment and write where all the dashed line tropopause, stratopause, mesopauses stop in terms of their elevations. Okay, I'll wait for you. All right, hopefully you guys did that. And let's move right on. This is just a different version of the same kind of chart. And you notice the pauses where temperature reverses direction, and this yellow line zigzags all the way up. And in the troposphere, you can see it's zagging or zigging to the left, and that's because temperature, which is on the x-axis, is decreasing with altitude. And then you see as the clouds pretty much come to a halt, and we reverse or pause and then reverse direction, the yellow line zigs to the right. And that's because temperature increases in the stratosphere, remember, due to the ozone. And then back to the left in the mesosphere, and to the right in the thermosphere. So what heats the air up in our atmosphere? Oh, really, the atmosphere is the main reason that we're actually maintaining a warm enough temperature to survive. But our atmosphere is heated by the sun in many different ways, and it warms up the air molecules. Warm air rises, it evaporates water, cool air sinks and condenses or precipitates it. We'll learn a heck of a lot more about that later. But let's just focus on temperature right now. So what's temperature mainly affected by? Well, first of all, we know in the summertime there's a higher intensity of sunlight and a longer day or a longer duration of sunlight. And so that really has a big effect. That's why it's one of the reasons why it's warmer in the summer. And cloud cover. Clouds can reflect sunlight in the daytime if there's a lot of clouds, and lack of them, more sun hits the ground. At nighttime, it's kind of the opposite. Clouds kind of keep the infrared heat, the Earth's radiated heat in, and keeps the Earth a little bit warmer at night, whereas if you have a night without clouds, it gets a little cooler. Cold and warm fronts, which we'll learn more about later on in this unit, they change the temperature. They carry temperatures from somewhere else and bring it to us. And how far you are from large bodies of water. So if you live really close to oceans or big lakes, we're going to learn how that affects temperature. And if you don't live near a big body of water, how that does too. Okay, temperature. Focusing once again on temperature. Temperature is the average speed or kinetic energy of the molecules in a substance. That can be measured in degrees Celsius, Fahrenheit, or even Kelvin. You can see in the picture on the left, the cooler temperatures, those molecules, there's less of them and they're moving slower, whereas on the right, this is a hotter substance here, or hotter gas, and the molecules are moving around faster, there's more of them. Now, there's often a big misconception between temperature and heat. Students mainly don't know the difference between the two. Heat is really a transfer, and we're going to do labs on this coming up in the next unit. The transfer of thermal energy or heat energy from something with a higher temperature to something with a lower temperature. And there is a difference. You can think of temperature as the average of the speed of those little movements and vibrations of molecules back and forth, like the boxes up above. Heat is just a measure of the energy given off by one object and then received by another. Like if you put your hand on a warm light bulb, and the heat that light bulb gives you is, it has a temperature, the light bulb has a temperature, but it's giving you heat, energy. And that's the difference. One way I like to think about it is to compare a bathtub and this spoon. Now imagine a teaspoon of boiling water. That'd have a higher temperature, be 100 Celsius, hotter than a bathtub full of lukewarm water. Let's say the bathtub's at, I don't know, like 90 degrees or something. However, the bathtub has more heat energy, way more heat energy, because the total volume of those moving water molecules in the bathtub is much greater. It has a mild temperature compared to that boiling water in the teaspoon, but there's just so much more of it. So it has more heat. The total kinetic energy of all the atoms of water in the bathtub is much greater than the total kinetic energy of the atoms of water in the teaspoon. So the temperature of the teaspoon is hotter, but the energy is less than in the bathtub, which is cooler. So now we can see how a substance's temperature and its mass determine how much heat energy it has. It's not just the temperature, it's how much stuff is at that temperature. That matters. Okay, we're going to do some of these conversions in a minute in our notes. I'm not going to mess around with it right now, but just safe to say that in middle school you had to learn a formula to convert from Celsius to Fahrenheit and vice versa. And now in 9th grade in Earth Science, you just simply use this chart, going back and forth between one type of temperature measurement units to another, Fahrenheit to Celsius, Celsius to Kelvin, and vice versa. So we're going to do all these conversions a little bit later on. I'll come back to this. And the last thing that we'll practice, and we'll do this later on too, is some isotherms. And we've done this way back in Unit 1, but hey, nothing like practicing some more. So what we're going to do after this slideshow is done is we're going to start at 20 degrees. We're going to connect the isotherms that are all 20s, and then we're going to increase by 10-degree intervals. And hopefully it won't be too complicated, but you never know. Okay, so hopefully you guys learned a little bit about why Earth's atmosphere is layered and about heat versus temperature.